Hi, this is Ron Matino. You have probably wondered why multimeters differ so much in price. You can pay $5 for a multimeter and it'll work, while some models sell for as much as $1,000. All the differences, in fact, come down to just 2 points: measurement accuracy and features. All digital multimeters, also called DMMs, including the inexpensive ones, can measure DC and AC voltage, DC current, resistance, can check diodes and transistors, and circuit continuity. Cheap devices like this one are also infamous for their poor reliability. They can fail on their own, and their wires can fall off the probes. Also, inexpensive DMMs can measure current only in DC circuits. The selection knob present in every multimeter is responsible for choosing measurement mode. You must set it depending on what you're trying to measure. Each mode has a separate corresponding section on the dial. The voltage section is marked with a V. Current section is marked with an A, for amperage. Resistance measurement section is marked with Greek letter omega, which is used to designate ohms in physics, resistance measurement units. The type of current measured is indicated next to letters A and V. Alternating current is designated with a wavy line, direct current with a straight line. Some devices simply have designations AC or DC. In some multimeters, you have to use the select button to switch between them. If you confuse AC with DC while measuring voltage or current, nothing bad will happen to your DMM, but the readings will be messed up. Once you've set measurement mode, you need to choose the maximum limit value that you're going to measure, also referred to as range. Ranges in digital multimeters are usually designated with a number and a modifier: milli, micro, mega, and kilo. For example, 200K in resistance section means that this mode will allow you to measure resistors up to 200 kiloohms. In a similar way, 200M in voltage section means you can measure voltage up to 200 millivolts. 200 micro A in current section tells your DMM you're going to measure 200 microamps max. If the actual measured value is above the range you have set, the multimeter will display OL, which means over limit. Some DMMs display a 1 with a period in such situations. Measuring voltage. Voltage is always measured between 2 points by applying probes in parallel with the component or power supply you're trying to measure. Let us measure wall outlet voltage. We have to choose AC mode and max limit value 600V. If we are in Europe, we cannot choose the 200 volts range because outlet voltage exceeds this value. Important: when measuring high voltage, you may not hold probes with both hands, because in the unfortunate case you may be electrocuted, the circuit in your body may run through your heart and kill you. Always use one hand at a time to measure outlet voltage, or insert probes one by one. Portable power sources like batteries are measured in direct current mode. Obviously, any device powered by a battery also uses DC. Let us measure a AA cell. Its nominal voltage is around 1.5 volts, so we use the 2 volts knob position, which is above this value. In DC mode, your DMM also displays voltage polarity. If you switch probes, that is, apply the black one to the positive pole and the red one to the negative pole of the battery, the multimeter will display voltage with a minus sign. This is to aid you in finding out a battery's polarity if it's unknown. A typical AC wall adapter may sometimes output either DC or AC voltage, which in fact will always be indicated on its label. To perform measurement, you have to put your DMM into the appropriate mode. From a beginner's perspective, the range setting is somewhat far-fetched. Why is it necessary? And why can't the DMM figure it out itself? Okay, consider this example. If you've ever driven shift stick or seen someone else drive it, you probably know that you have to change gears as you accelerate. And it is necessary because the engine cannot develop high torque when RPM is low. So you cannot accelerate to 100 in the first gear. You also cannot go 10 mph in the fourth. You have to choose gear according to the speed you're traveling at. Similarly, in a multimeter, you have to choose range based on the amplitude of the value you're trying to measure. Think of it this way. The range setting, in fact, adjusts input sensitivity. By choosing a low range, you make your device more sensitive, but also more vulnerable. By choosing high range, you protect your instrument from possible damage, but at the same time, significantly reduce its sensitivity and measurement accuracy. For example, if you set your DMM to 600 volts and try to measure voltage of a mobile phone battery, the LCD will read 3 volts instead of 3.7, giving you a rounded value. Here's what it looks like on a properly chosen range setting. So it's basically the same as with an analog meter. Set the sensitivity too high, the device will go off scale. Set it too low, the arrow movement will be too insignificant, and it will be hard to get an accurate reading. The skill to choose range correctly will come with experience, just as an experienced driver shifts gears intuitively. But when measuring high voltage, remember that setting your multimeter to a wrong range will most likely damage it. Always double-check your DMM's knob setting and probe placement when measuring high voltage. Measuring resistance. Resistance is the ability of a material to resist the flow of electric current. To measure the resistance of a component, just touch its leads with the probes of a multimeter. Note that it is necessary to ensure proper electrical contact. If you need to measure a component whose resistance is unknown, it makes sense to start at the 20K setting. If you get the OL reading, open loop, no continuity, it means that the resistance is too high, and you need to set your DMM to a higher range. If the reading is near 0, it means the resistance is too low and you have to lower the range setting. Important: when you measure resistance, you should not touch the metal tips of the probes with your fingers. Your body also has resistance, and it may affect measurement results. You should also not perform measurement in circuit. Neighboring nodes and components also have resistance. This may affect the result. And most importantly, resistance cannot be measured when the circuit is powered. Make sure to always turn off the power supply of your circuit before doing the measurement. Note that it is necessary to ensure proper electrical contact. Dust, dirt, moisture, and oxidation may affect measurement. In some cases, component leads may need to be cleaned. Resistance measurement mode is really versatile and can be used to test many other components. For example, you can check a solenoid or a transformer for continuity, or the windings of an electric motor for short circuits and ground faults. When performing measurement, be warned that inexpensive DMMs may demonstrate effect of so-called complementary resistance. Normally, if you short the probes, the LCD should read 0 ohms. However, a cheap multimeter, as we can see, displays a different value, which depends on a number of factors, most importantly, the quality of wires used as probes. In practice, it's often necessary to differentiate between a real short circuit and a low-resistance circuit. For example, the normal impedance of a video card processor, GPU, ranges from 3 to 8 ohms. But if it's below this value, the GPU is probably dead. You won't be able to tell it, however, if your DMM adds another 10 ohms to the actual value. So, before doing such measurements, make it a rule to first short the probes and find out your device's complementary resistance, and then test your circuit, considering the error value. If your multimeter has the rel function, you can use it to rule out the error. We'll talk about this feature a little bit later. A variation of resistance measurement is the continuity test mode. In fact, this is just the lowest range of this mode, in which, for your convenience, the DMM also generates an audible tone when a circuit is detected. Using continuity test, you can troubleshoot shorts in a cable or determine which wire goes to which contact. Please note that a tone is generated only when the resistance is lower than a certain factory pre-programmed value. My multimeter's manual states it's 10 ohms, but in reality, turns out it's twice as high. Okay, we are now ready to formulate the first and basic rule that needs to be learned. Always choose the correct measurement mode and range based on the characteristics of the signal you are measuring. Be aware that selecting a wrong range or mode when measuring high voltage may damage your multimeter. These days you can buy a DMM with automatic range switching. As we can see, its knob dial has no numbers, but only modes. However, current measurement is still split into several ranges. The 10 ampere port is also present. Automatic range switching is supposedly a very useful feature. However, personally, it took me some time to get used to it, because it turned out that auto-range multimeters work way slower than regular ones, because the device needs to decide on the range every time you make a measurement. Also, if regular DMM is all you've used before, you'll always find yourself wanting to grab the knob every time you go, say, from measuring a AA battery to measuring the wall outlet. Here's a little life hack I've come up with regarding the mode switching knob. We often put it in the wrong position. For example, the 250 volts and 2 kilo-ohms modes are exactly on opposite sides of the knob, and it's quite easy to confuse them. So here's what you want to do. Mark the knob's pointer with a piece of bright colored paper. This way, you'll never make a mistake again. And here's another rule to remember. Unless you want to damage your multimeter, never change knob position while performing the measurement, especially if you're working with high voltage. Measuring current. To measure current, you have to attach your multimeter in series with the circuit being measured. You probably know that most DMMs have 3 or more probe ports. Next to each port, there is a designation indicating modes in which the port is to be used. We can also see the word fused here, which means the port circuit is protected by a fuse. Unfused obviously means the port is not fuse protected. COM means common. You must always connect the black probe to this port, and basically there's no reason to ever move it. The 10A port is used to measure current from 200 mA up to 10 ampere. The rest of the measurements are done with the remaining port. In fact, the 10A port mimics another position of the mode knob, providing an additional range to measure currents up to 10 amperes. The reason it's not on the knob itself is because the mode switch contacts are too weak to carry 10 amps of current, so the 10A port is wired directly to the internal shunt used to measure current. Please note, the 10A port function does not change when you turn the knob, meaning that if you, for some reason, forget to remove the probe from the 10A port, even if your multimeter is set to voltage or resistance, once you apply probes to a power source, you will get a short circuit, and the shunt will most likely burn out. Some DMMs have a fuse in series with this port, but this one, as we can see, doesn't. So here's another important rule you've got to remember. Never leave the red probe in the 10A port. Move it back to where it was once you've finished measuring current. Also keep in mind that you may only measure high currents for 15 seconds max. If you ignore this requirement, the shunt inside the multimeter may overheat and burn out. Inexpensive DMMs are often equipped with shunts of poor quality, whose resistance may amount to as much as 2 to 3 ohms, which also contributes to complementary resistance that I mentioned earlier. As the ammeter is connected in series with the load, this may affect both your circuit and measurement results. The higher the current you're measuring, the bigger the error. So cheap multimeters are not really fit for measuring currents above 1 ampere. In case you need to measure current of an electric motor, especially if it's a fridge or an air conditioner compressor, you have to keep in mind that their inrush current may be significantly larger than their normal working current. So, if you try to use your DMM to measure it, the inrush can kill the shunt. So, here's a life hack that will allow you to make this measurement and keep your multimeter safe. Wire your DMM, like usual, in series with the motor. Attach a switch in parallel with DMM and close it. Start the motor and wait for it to pick up speed. Now, open the switch and have your measurement. And here is an important one. You may not measure current of a power supply without a load. Needless to say, you cannot measure current in the wall outlet. Not that it's not present. In fact, there's actually too much of it in there. If you attempt such measurement, it will result in a short circuit and will kill your multimeter the instant you try it. Remember, the only measurement you can do in the wall outlet is voltage and frequency. We'll discuss measuring frequency later on. Diode testing mode. Diode testing mode in multimeters also has a separate dedicated knob position. In some devices, it's combined with continuity testing mode. Diodes are semiconductor devices. They have nonlinear current-voltage characteristic, which means they do not have constant resistance. Instead, they demonstrate constant voltage drop. So, in this mode, your DMM will display voltage falling across the probes, not resistance. If you didn't know it, hit the like button right now. When working with semiconductors, there's one thing you must keep in mind. To test a diode, your DMM must apply enough voltage to switch it on. And while for regular diodes it's about 0.7 volts, for LEDs it's from 1.5 to 3.5 volts, depending on the color. So here's what the problem is. Most multimeters cannot produce voltage that high, because they are only powered by a couple of AA batteries. So if you plan to test LEDs, you'd better off buying a multimeter powered by a 9 volts battery. For a quick comparison, here's the difference of voltage across the probes of a AA powered and 9 volts powered multimeters in semiconductor testing mode. As we can see, the odds of illuminating an LED are much higher in a 9 volts powered DMM. Also note that voltage necessary to turn on white LEDs is the highest, so you should probably not rely on any regular multimeter if you need to test them. Semiconductor testing mode also allows to check transistors and find their pinout. The HFE knob position tells current gain of a transistor in question. By the way, HFE, also referred to as beta, stands for Hybrid Parameter Forward Current Gain for common emitter, and is the most basic relevant parameter found in a transistor. So if you have inserted it in the measuring socket and your DMM displays an integer number on the LCD, you have positioned it correctly, and the letters on the socket will tell you the pinout. And here's another important rule. After you've finished with the transistor, remember to remove it from the testing socket. Otherwise, your DMM may produce wrong measuring results in other modes. Additional features. What additional features could be useful in a multimeter? I would say it's capacitance measurement. Because electrolytic capacitors are pretty expensive, hobbyists often use salvaged components. But as we all know, using faulty parts in your circuit may lead to a lot of frustration and time loss. So if you're up to using salvaged caps, you really want to own a DMM capable of measuring capacitance. And here's another tip. Before testing and measuring capacitors with your DMM, don't forget to discharge them. Otherwise, you may end up with a wrong measurement or a failed multimeter. Another extra feature that can be found in some DMMs is frequency measurement. Probably for most people its only use would be measuring AC frequency in the wall outlet. If you're up to developing or repairing high-frequency stuff, like power supplies or digital circuits, to be honest, it's much more convenient to use an oscilloscope, because you also see the waveform and can have a better understanding of what's happening in your circuit. So, in my opinion, frequency measurement function in a multimeter is sort of abundant. In some DMMs, though, this function can also measure duty cycle. This is useful when working with circuits utilizing pulse width modulation, or PWM. Duty cycle is the ratio of time a load or circuit is on compared to the time a load or circuit is off. Simply put, it's the percentage expressing the intensity of feeding power to the load. Because PWM is widely used nowadays, you may find the duty cycle measuring function useful. The only question, though, is how accurate your DMM can get in its readings, and at what frequencies. One more additional feature that some DMMs have is temperature measurement. This can actually be useful if you have a soldering station with a hot air gun. It is known that the thermometer at the gun itself does not usually provide an accurate reading, because temperature must be measured directly at the part being soldered. So, a multimeter with an external thermometer can be used when working on surface mount devices, SMDs. Fortunately, even inexpensive DMMs are often equipped with a temperature sensor. Some multimeters can also measure inductance. In my opinion, it's an interesting feature, but it's pretty exotic. I would say this function might be useful for people who make inductors for the circuits they build. But even if you're a hobbyist, you can always buy a ready-made choke or a transformer with known parameters. Auxiliary functions. Out of all auxiliary functions, I would say the most useful one is the auto-off feature. In my Unity 33A, however, its implementation is sort of messed up. The DMM unconditionally shuts down about 30 minutes after it's been turned on. Whether you are measuring anything at that time or not does not matter. The thing will go to sleep anyway. No matter what, the auto-off feature in a DMM is a very useful one, and I highly recommend it. There is, however, a sort of a downside to it too. Once you get used to this function, you keep forgetting to turn off your other devices that do not have it. So you keep replacing batteries all the time. By the way, if your multimeter displays a low bat sign, the battery must be replaced immediately. The thing is, most multimeters, especially inexpensive ones, will produce incorrect readings when powered by a weak battery. So, to avoid errors and frustration, do not allow this. There's a number of yet additional features some DMMs have. For example, relative mode, the rel button. If it's activated, only change of measured value is shown instead of an absolute value. For example, if you started measuring voltage and it was 3 volts and then increased to 4.6 volts, 1.6 volts will be displayed on the LCD. There are also min and max functions that show the minimum and maximum value for the entire measurement time. What is the practical use of these functions, you may ask? Well, the max function may be used when you need to measure inrush current in a circuit, for example. The rel function is useful in resistance measuring mode, when you need to compensate for complementary resistance of probe wires, something I already mentioned before. Some multimeters also have a signal generator. Obviously, that one may come handy when testing signal flow in analog circuits. But in this mode, the multimeter can no longer perform measurements, as it will be busy generating. So it looks like then you need an extra measuring device to check for a signal at the output of your circuit. In my opinion, the signal generator in a multimeter is pretty useless. True RMS. You have probably noticed that some DMMs proudly bear the True RMS logo. Usually this feature is only present in expensive devices ranging from $100 and up. In essence, True RMS serves the purpose of properly measuring AC signals with imperfect non-sinusoidal waves. For example, if you're up to measuring current or power consumption of an AC LED light bulb, you simply cannot do it with a non-RMS multimeter, because your measurement will be way off. The reason basically is the nonlinear IV curve of LEDs. To correctly measure non-sinusoidal signals, an RMS multimeter uses a DSP converter chip based on the notion of equivalent heating value, meaning a 1 volts RMS AC waveform generates the same amount of heat in a resistive load as will 1 volts DC. So the RMS to DC chip uses a complex algorithm to calculate correction factor. Because these DSP chips are pretty costly, obviously you cannot purchase a True RMS multimeter for $20. The most affordable DMMs that have the True RMS feature are Unity 61D and Unity 61E. These multimeters use the 8737 RMS converter chip from analog devices, which provides 1% accuracy at frequencies up to 10 kHz. This IC, by the way, alone costs as much as half a multimeter. There are a number of cheaper devices that also claim True RMS support, but in practice their readings are only accurate at low frequencies. I assume these DMMs use a certain programmatic algorithm which heavily relies on the main CPU. So if you're up to buying a True RMS multimeter, please do watch some YouTube reviews and find out how this feature is implemented in a particular device you're planning to purchase. To sum it up, always correctly choose measurement mode, especially when working with high voltage. When measuring, do not touch the probes with bare hands. Push on the probes to provide proper contact. To avoid errors when switching modes, put a bright mark on the main knob. When measuring high voltage, do not use your both hands. Remember to remove the red probe from the 10A port after measuring current. When measuring current or resistance using an inexpensive DMM, consider the error caused by the probe wires. If the low bad sign appears on the LCD, replace the battery immediately to prevent false readings. And also, remember that your multimeter, just like any other device, comes with a user manual. Believe it or not, sometimes it does make sense to read it. And finally, here's a couple of life hacks I would like to share with you. If you need to determine the hot wire in the wall outlet and you have no indicator screwdriver at hand, use this method. Put your DMM into AC voltage mode, the highest range. Then attach one probe to a radiator or a water pipe, and use the second probe to touch the outlet's contacts, one by one. Whichever contact you get a voltage reading on is the hot wire. The second life hack will help you find a faulty connection in a UTP cable. If you've ever crimped network cables, you probably know that sometimes you end up with a short circuit in the RJ45 jack. They are really easy to detect with a network cable tester. However, the tester will not tell you which of the two connectors causes the short. In this situation, most people would cut off both jacks and recrimp the cable. However, you actually can figure out the faulty jack using an ohm meter. After the LAN tester had shown you which of the two wires are shorted, use the multimeter to check their short's resistance on either side of the cable. Whichever jack you get a lower resistance reading on is the one to be recrimped. And finally, here's a little brain teaser for you. Big part of this video is dedicated to explaining ranges and how to correctly set them on a multimeter. Have you noticed that most values are tied to a 2? 2 volts, 200 kiloohm, 20 milliamps. Why not 300? Why not 50? What do you think? Comment. And that would be it for today. If you liked this video, please give me a thumbs up and share it on social media. I'd be happy to answer your questions. And if you wish to support the channel, you can send me some Bitcoin or Ether using wallet numbers found in the description. Also, don't forget to subscribe to this channel if you haven't already. This was Ron Martino. Be good.